So hi everyone, good morning. I'm Varun, he's Shadab, he's the one doing all the cool things, I'm the one just architecting things. And from one Varun to the other, I'll take the stage now. But I'm sure I'll stick to the time. So today, the topic that we want to choose or talk about is data trust. So fundamentally, when we talk about data or data trust, what is the first thing that comes to our mind? It is to get the quality of the data in check and making sure that we have the right data in the right place for the customers or for the business users to consume. But what we tend to forget at times is, apart from data quality, there are a lot of parameters and matrices and checks and entire universe of the information that you need to also understand to make sure the data can be trusted. So today we'll deep dive into some of those aspects and how at MathCo we are solving some of those challenges, or we have gone into that journey to solve the challenges. So we have not done it completely, as you know, it's an ongoing process, but we have taken a good stride towards that. Shadab will also cover that as well. Right? So we'll first focus on what is data trust, why do we really want to talk about it, what are the impacts if the data trust goes wrong, so on and so forth. Right? So if I simply talk about data trust to start off with, right, as a data engineer, I've worked out as a data engineer all through my life. Right? Even right now I talk about, hey, I'm a data architect, but at the end of the day, fundamentally, I'm a data engineer and I want to call it that way. So if you talk about data as a data engineer role, what we do is, okay, let's throw technology at the problems. Let's make sure that we build some data quality pipelines, some checks in Python, do some checks in SQL, and we are done. And we'll say, hey, business, don't complain what has happened in your data set. We don't care. But that's not the overall objective of data trust, right? So what we need to start off with is to make sure we understand business is in the process of data trust. So like accuracy, completeness, timeliness, all the factors, the matrix of the data quality that we are so used to hearing and has become all of a sudden a cliche as well, right? That is something that business wants to understand fundamentally to start off with before we as engineers throw problems and technology at them, right? Then the critical idea about data trust is to make sure your consumers of the data are involved in the entire journey of the data trust. I'm sure majority of you know this already, but not many of us practice it every single day. Also, what we need to ensure that apart from the quality checks, apart from making sure business are integrated, they also see unified layer of the data. So there is a concept coming around and doing a lot of rounds of semantic layer. Why is semantic layer needed? Then again, there is a concept of data marketplace. Why is data marketplace needed? This is all to bridge the gap of making sure the last mile delivery of data, that is to the end consumers, is consumed the right way. So we'll talk some of those and how data framework that we think can go towards that, right? Now, if you have to throw technology at it, of course, we know the usual suspects of, hey, we need to make sure the data quality coverage is right, we need to make sure alerts and notifications are in place, the producers and consumers are all in one place, there is a robust ops that is going into it, and of course, we cannot forget catalog and lineage, which is the fundamental around data governance, but still we cannot solve that problem because there are so many tools out there in the market. There is Atlan, there is Colibra, there is Monte Carlo right now bringing in their observability layer. There are so many tools and technologies, but what we need to fundamentally understand is, does this solve our business problem or not at the end of the day? That is data trust for me, and I think that is how we look at data trust as well. To start off with business and then transition over towards the engineering side of the problem. Now, if you have to talk about data trust in a simplistic representation, this is how I would talk about. You have one bunch of sources, then you push it to a staging area, you have warehouse. I come from ETL background, so warehouse and staging area are like my bread and butter, and I enjoy talking about it every single day. And then you have, of course, the analytics layer on top of it. Right? But simplistically, how we do it is, we project the quality matrix to the data quality dashboard, and that's about it. That is nothing but the 101 of data trust and building that data trust. But that's a one-dimensional view of the data source, data success or failure, right? We are projecting the data. Now, one other thing that I want to also call out is Excel is not a friend for data engineers. So don't please project your quality metrics on an Excel. It has to be on a dashboard because Excel loses the authenticity of the data. It does not allow to push the data to data's authenticity because there is no historical storage. You cannot project, you cannot do anomaly detection, nothing. So from day one, please start projecting your data onto a dashboard. Again, this from my experience or what I've seen in the past, everyone may have a different opinion, and I'll not contest that at this moment, maybe offline. So if you have to talk about data trust toolkit, right, there are majority of the tools in the market. But if you have to really focus on, we focus on data quality tools like Great Expectation. We all have great expectation from Great Expectation, and it is living up to the expectation as well. But at the same time, we need to understand how we leverage that as well, right? And then there's DBT, which is like the favorite kid in the market for data warehouse people, right? Where you can also do quality check. DBT has integration with Great Expectation as well. So you can do all of that. I mentioned Python and SQL as well. One of my colleagues was scanning through this deck and he asked me, hey, why have you put Python and SQL? I said, without that, you cannot do the data quality at all. That's the fundamental that you start off with. And then, of course, Scala, of course, if you're a Spark fan, you have to get Scala also integrated. There are a lot of data observability tools, data cataloging tools, monitoring and business intelligence tools. But fundamentally, what we need to understand is data trust cannot be built by just quality. There are a lot of tools that comes along with that. And that's just a representation of what comes to my mind right off the bat. There can be plenty more, apart from this, right? Now, if you have to deep dive into MathCo's and our fundamental understanding of what data trust framework is, I can talk about into 5 different layers. So read it from bottom to up, where first of all we ensure that the data sufficiency is there. That means we need to ensure that the data layer is created. All the data lake or lake house or delta lake or warehouse, whatever you may call it, the name doesn't matter. But first of all, the fundamental understanding of getting data into place is something you have to start off with. That's the data sufficiency. And then you build it on top and bring the data quality and observability layer on top of it. Now, if you see today's topic, we'll deep dive more into data quality and observability, but fundamentally we understand to build the data trust for an organization or for any business unit, you have to have these 5 layers. You can have much more. Of course, data privacy and security is always there. You have to integrate that. Now, if I talk about catalog and lineage, you can exchange catalog and lineage and data quality. You can contest that, hey, I'll first build a catalog and then I'll talk about data quality. Sure, you can do it. But that's just a representation that I thought is fair for the understanding of data trust. Then, of course, semantic layer like I talked about, right? So I was exploring this tool called cube.dev, which is very interesting. I think you should go and explore as well how they are solving the problem of building semantic layer with their integrations through APIs, through the caching layer of the semantic and all of that, right? We are also conversing with one of the customers where they say that, hey, we have data into multiple sources. We have data into BigQuery, we have data from cloud storage, of course, we have it in Hive. Now, of course, fundamentally, Hive is built on top of cloud storage in their cases. But how can you build semantic for us in that cases, right? So we are trying to solve that problem as well using some of the tools that I mentioned. And then, of course, marketplace, which is my favorite topic, and I keep talking about it every single day. My colleagues are bored to death with that. But still, I keep talking about how do you ensure that you have a unified view for the consumers, right? So if I really deep dive into the marketplace, then it is fundamentally saying that, hey, you get your data into one place to project it to your end consumers, where they can see, hey, who are my data owners, what kind of classification my data is, whether it's a PII data or not, if it's a PHI, PDI, whatever. And then also on top of that, can I see the matrix and the reports in one single unified place? So that's the idea the world is moving towards also, to bring in the data trust. So data trust cannot be fundamentally just be data quality. It has to be much more than that. That's the idea that we want to present here as well. We'll deep dive into all of that, and also one more thing we have to understand is, apart from data engineering, of course there is a complete stream of data science as well, right? There's always a twist between data engineers and data science, and that will continue forever. But what we need to understand is, to make sure the ML models can be consumed in a proper way, we can trust the models that the data scientists have built. We have to ensure that the data trust is also there. The concept of data drift and how we are solving for that is something also we'll touch upon, but we can take some of the nitty-gritties later on as well. Now, I'll just quickly touch upon, I'll not spend too much time of data quality in the industry, etc. But overall, if you have to talk about the data quality maturity curve, it starts with very chaotic, hey, I don't understand my data at all. I just have no data quality, or I'm doing data quality on Excel. So that's also a chaotic way of representing your data trust or data quality. Then, of course, when you move forward towards this, it's more reactive way of saying that, hey, I have lack of coordination between the producer and the consumer. So your consumer can be a downstream pipeline. So let's say you are building an airflow pipeline that is dependent on multiple 3-step process before you reach to the last mile delivery to your business user. Then in that case, your consumers can be a multiple airflow pipelines as well, DAGs as well, right, in the airflow world. So that also has to be clearly defined as to who are the producers and consumers and how they are interacting or coordinating between each other. And there are no clear owners of data, then everything falls apart, right? So let's assume that there is a marketing data you are pulling from your Google Analytics, and you are doing a bunch of metrics, but you don't know who do I contact if the data quality fails. You just don't know that. Then that doesn't help your problem, right? So there are tools, of course, to support, but ideally what you should go ahead and just throw out a survey to your consumers and say that who owns this data. If you don't get an answer to it, then the next step comes in of how you throw tool to your data, right? Or to your consumers. But you cannot start with throwing tools all the time to your consumers. And then of course there is a measured way of saying that, hey, I clearly define the ownership of the data. Who are my data producers? Who are my data consumers? So there is you can in the blog data contracts. So data contracts essentially talks about you have a producer, you have a consumer. They come into a digital contract saying that I will basically, producer says that I will produce the data in a particular quality metric, and consumers say that I also want a data metric in a data quality rather in a particular format. Once they define that metric and the rule definition, that gets stored into a database. You can project an API on top of it to integrate to your data pipeline or to your visual interface of marketplaces as well, for that matter, right? So that's data sorry. Okay, I forgot. Sorry. Data contracts. People are listening. Thanks for that. So then there is optimized view, right? Where basically we are saying that we have all in place. We have all the data trust in place. We have also created marketplace. We have catalog, lineage, everything. But still, we would not call it as a mature, because we cannot ever call our quality or data trust entire journey as a mature, because it's an ongoing process. It will never be mature. It will always be reaching a stage of optimization and re-optimization as we move along the journey, right? So that's a fundamental understanding of how you can see your data quality metric maturity curve as well. Now, if you really get into some techniques, then you have to of course plan for your data quality. You say that, hey, these are certain rules that I need to define. I want to say that, hey, I want to do some not null checks. I want to do some other checks of let's say conditional checks. I want to do that the range of the value should be in a particular format, or the row count should be in a certain format, right? And then you can throw your anomaly detection on top of it if you need, right? And then you basically design the data quality as well, right? Where you integrate with your data pipelines. So first, we should not start with integrating the data pipeline altogether before we define the rules, of course, and talking to the business. But then, of course, you start with defining the integration with the rules, pipelines, and then you have reporting and everything. Please don't report on Excel. I cannot stress this enough. And then you can define the data contracts if needed, right? Data contracts, again, it's not important all the time, but eventually to reach that maturity, since it's something out there in the market, I think we should all try it as well before we see that what happens, where it takes us, right? We have tried the data contracts. It's pretty cool because it gives you a lot of visibility into your entire system, but that's one thing that you can do. And then you can build catalog lineage that I already talked about, and then finally enhance and monitor, right? So that's all I wanted to stress upon, how we can build the data trust overall. So we start off with all the layers. Don't see data trust only as a data quality metric. See much more beyond that. I'll hand it over to Shadab, who will more deep dive into the data quality accelerator we have built and how we are trying to solve that problem. Over to Shadab.
Thanks, Varun. So Varun has already covered almost most of the parts of data trust. Now you would have some basic understanding like what data trust framework is, and we are building an accelerator basically within MathCo, which is trying to where we are focusing on data quality and drift part, the monitoring aspect specifically. So there are many tools out in the industry, right? How many of you have faced issues while, let's say, if you're going to use some tool for drift monitoring or any tool for data quality check? Is it easy to integrate with the pipeline or with the project what you're working on? No, right? We face a lot of challenge when we try to integrate, even though we have the existing tool, but the scalability of those tools, the integration of that tool, the customization we need when we want to play around that tool, it takes a lot of effort. And with the changes and updates happening in the industry, the adaptability of those tools is also a challenge for us, right? So considering those pain points and many other features, what we finalized when we were thinking of this accelerator, basically, we came up with certain set of features and the capabilities which we integrated with this framework so that that act as a key differentiator for us. So if I talk about the capabilities, right, so this accelerator is basically a cloud agnostic platform, or you can say a tool package, whatever you want to call it. And it can be deployed on any of the cloud, be it Azure, AWS, or Google Cloud, or even if you have on-premise server, like you're not working on any of the cloud, you can go for the deployment here as well. Then we have continuous monitoring enabled for the metrics and reports to generate the reports basically. We have reusable dashboards also, and anytime the dashboards are not directly consumable by the client side, they might look for reports in the format of PDF or HTML file. So we have that capability as well integrated within the framework, within that tool, so that if there is a need of a specific report needs to be generated in a certain format, be it HTML or PDF, we send that to the configured emails. So we have a notification system, notification alert system through email, team, and Slack channels. And then we have, like we're following the industry standard for building this framework. So when I call about industry standard, right, it doesn't just include the data engineering practices or design patterns or coding practices. Obviously, we are following up to the best with in those areas. But apart from that, we are integrating the domain knowledge we are bringing from the years of experience of different SMEs working in the MathCo. So be it retail industry or some other client you can think of, right? We are understanding what tests do they need for different KPIs, for different kind of data sets, and based on that, we are bringing all those knowledge in this framework, customized here. And we are overall for this framework, right, to build and establish the trust with the data what we are going to use. We are calculating data quality trust score as well, like an aggregated score for all the tests and checks we have performed on the data. And that is built on top of the 5 pillars. And these 5 pillars are not necessary that every client will be going with that. It can be 3 for some, 4 for any of maybe more than 5 as well. So just to name those pillars, we have certain tests for checking the accuracy. We check for the reliability of the data. We check how much data is relevant for us, what we are loading, and then timeline is whether the data is getting refreshed timely or not, and completeness of the data. Do we have required number of rows or required number of columns in the data or not, or the data which we are getting from the data source is having some missing rows or columns come to it. So these are the 5. Apart from that, there are many other pillars as well, like integrity checks and all, which we will see further. So this basically overall, if we talk about this framework, right, this helps us in accelerating doing the data quality check and monitoring capabilities in at least 2x faster time for the clients. So to summarize that, these are the key objectives where we have centralized data quality knowledge given or shared with different stakeholders for the client through dashboard and reports. We have reduced the time to generate the value for the organization. And we are following best practices for data engineering to build this framework. And this is how we are improving the trust on the data. And we are considering design philosophy as well, like we are tech and business agnostic. And apart from that, we have kept the monitoring and data quality capabilities decoupled from each other so that the tool is robust enough and modularized. So that if someone just needs a data monitoring capability, right, like data driven, model monitoring, feature attribution and all, then they can just plug and play with that component, and if you need the whole framework, you can go with that too. Scalability is major challenge, right? How many of you have faced challenge when you tried using any of the drift package to calculate the different test values basically, if you have millions or billions of records, for example? That's another major challenge, and even we have gone through that phase where we were really struggling to calculate the test values in real time for the data set we are working with. So that's why, like, we have built this on top of the Spark, Polars, Pandas, all those like design framework packages we are using to build a framework. And we are also like following the test-driven development. So whatever test cases or functions we are implementing, right, we have unit test, system test, and integration test in place to test the whole framework whether it's working fine or not. And then we have the observability. Like whatever metrics is getting calculated, that gets logged on the dashboard. And even if any anomaly is being detected, then the email has been sent in a certain format to the users. So this is the high-level architecture, abstracted architecture of the framework what we have built so far. So to explain this, right, so data will be coming to the source from many places, right? It can be Google Analytics or some live transaction data, or let's say some data is getting dumped to the BigQuery and all that. So that data will be coming to the source, and we will first do the freshness check whether the data pipeline is getting refreshed timely or not on the scheduled interval, and if that checks are done, and if any if the data is not refreshed properly and all, the alert system is in place which will take care of informing the stakeholders over there. Then we have data contractors as well, which data contracts basically establish certain rules between data producers and consumers. For example, let's say if the data is coming from the Google Analytics site, and a user is searching for mobile devices, and he just typed MOB and he got the recommendation over there and he selected. But the data which will get logged will be MOB, right? Then we should have some rules to map that MOB with the keyword what we are interested in. So that's how the mapping is being done. And all those rules will be like logged in the rule store. And that rule store is again the part of the data quality framework which we have built. Once the data has been, the ATL job has been completed, the data gets dumped to the intermediate data store. After that, the main role of DQ engine comes, where we check for certain default checks are there which needs to be performed on different columns, like value level checks and all. Then we have integrity checks and compliance checks. For integrity check, we check for the completeness, reliability, and relevance. Then we have compliance check over there, and we need the understanding from the business as well, like what KPIs they are interested in, and what other checks they want to perform on those KPIs. So for that, we have business checks as well. And based on these checks, if any anomalies will be detected or any drift will be detected in the new upcoming data, then the notification system will notify the stakeholders. And the metrics which we are calculating from this framework, right, that will get logged to the exception data store, and from there it will get populated to the dashboard, and even the reports will be generated. So dashboard and reports, like either both can be utilized by the client or anyone, like whatever the need is basically.
Yeah, and just to add on to that, integrating the compliance checks, these are majority of the times input driven rather than output driven, because there is a lot of subjectivity that comes here. You cannot have a relevance or a completeness just based on looking at the data. At least that is not what we have observed so far. So a lot of the time the business have to give that relevance, completeness, also definition. That's where we'll talk about Codex as well, which is our platform that we have built in-house, right? Which caters towards the AI/ML and of course the entire data infrastructure there as well. That's where the subjectivity can be integrated into it, right? I just want to clarify that point alone, because it cannot be an output-driven metric all the time.
Yeah. And after that, like whatever metrics and analyses we have detected from this by using this framework, right, that goes to the flow controller, and flow controller is nothing. If any analysis is being detected, then the stakeholder will have to take the call whether they want to like continue further to dump the data to the sink, which is further connected to the train or inference pipeline in case of ML use cases, or just to the it can be consumed for reporting or insights as well directly from there, right? So after the usability check has been done, if let's say we take the example of train pipeline, if we are going to train an ML model over there, then the pipeline will be trained, and for the inferencing data for retraining the model, again we will be performing, we will have monitoring component over there, where we will check for data drift, concept drift, and feature attribution. So while working with data drift, again there are many packages, and most of them are built on top of pandas, and also the scalability again becomes very challenging over there. For example, if we just have 50 or 80,000 rows of data, right, which in real time you will not get that less data, it can take half an hour of time to run just a one test. Like those metrics calculation is that computation time. So we are solving that too with the help of this framework, like how we are like coding it, and then concept drift, again model monitoring is also important for us. And being an MLOps guy, right, since that's my core focus, the data trust and quality is very, very important for me as well, to ensure that ML pipeline is running smoothly, and the values, the instances which are coming from the ML pipeline is impacting the business outcome positively, not negatively. Because if the data has been drifted, obviously the model output will be the junk, and it will impact the business outcome negatively. And then we have feature attribution, where we are incorporating the explainability of the features, not just what we are using for training the model, but even the inferencing. For inferencing also, whatever model, whatever data is coming, right, we check the explainability of those features, whether they are like in line with the baseline data set or not, and we decide the threshold as well. Just to highlight few more features, like we do threshold recommendation also for different tests in monitoring components. Let's say in data drift, if you're going for Nathan-Sharon test or divergence test, right? So for a data scientist, if you're coming from a statistician background, then that's good. You might have a good hold on the stats. But if you're coming from different background, like let's say pharma or you're a computer science student, not only coming from the stats background, right? Then deciding on like what threshold value you should keep for this particular column, for this particular test, is biggest challenge right now, and no one is recommending that with the packages we have seen so far, right? So we are simulating all those, we are taking all that effort on us. We are doing the simulation and we are calculating those thresholds. And once you will use this framework for drift monitoring, for example, right? And you will specify the test, what test you want to perform. By default, also we have given certain tests, a group of tests which needs to be performed based on the type of columns, or based on the type of features we have. And we have segregated that based on the continuous variable, binary variable, or if you have time series data for that, also you can like perform drift monitoring and all. So this is high level.
Just to add on to that, I think the last part that Shadab was talking about is more to do with the MLOps component and how you can ensure that the trust becomes on your ML pipeline as well, right? So for all the data engineers maybe who are not that well versed with the data drift concept, it's for the MLOps pipeline representation. But the overall trust and quality needs to be done end to end. That's the representation that we're talking about. So some of the details we can also talk offline as well. But this is what just want to clarify that as well. Yeah.
So this was the basically high level architecture what we have built, and this is the illustrative diagram. We cannot reveal the real product what we have built, and the client data was new. So this is the dashboard which you will be getting for data quality check. So we have here the description of the checks which we are performing. Basically the project description will be here. This is the trust score. It's not visible clearly over there because of the screen maybe. But this is the high level score which you will get for like what trust you have, and these are the pillars which we have defined. This is the monitoring part, like if like whatever the data quality checks are being performed, that will be getting populated. And if you will select any of the particular features, right, and you want to deep dive, what are the like certain calculations which you are performing, let's say average values, mean, max, change. If those checks you want to perform, then these values will be getting populated over here. And over the period of time, you will see the histograms as well in the visualization format. So these graphs, values, and all tests are customizable, and you can select the views which you want basically. And this is the data drift screen. Here you can like connect the database from the UI as well. And sorry, I forgot one thing. Here you will have input form as well. So through this framework, right, we are trying to give more control to the users as well, so that you can configure certain things from the code, and certain things can be configured from the UI as well. So that user has maximum control of the framework what you are building. After this, yeah. So talking about the drift part, right? You can connect the databases and you can select the columns on which you want to perform the drift check. You can select the test also, and once you create that job, it will calculate the threshold, and on this screen basically it will recommend you the threshold and drift whatever has been detected. And if you want to update that threshold, you can select the features. So this here you can see this is one of the columns, and for this column we have performed these many tests. And out of these many tests, for whichever test the drift has been detected, it will mark that as drift detected, and we are also classifying that like what will be the impact of that drift on the overall data set.
Yeah, and also to add on to that, right? I think there are a lot of data quality tools, representations out there in the market, but one thing that we wanted to have a differentiator or detailed level analysis on was how can we make it really customized for domain specific. That's where our proprietary tool, Codex also platform rather comes into play, and all these representations on the data quality, the data drift. Right now, it's just an illustrative version for the larger audience, but we have like customized it for user as well, for retailers as well as for other industry verticals as well. So I think we are a little short on time as well. We'll take your questions offline, but Shadab, you can complete your point. We'll be outside. If at all, we need to have a good conversation, and we'd love to understand as well how you are solving, and maybe we can take some cue from that and learn and maybe explore more around that, right? So it's not a complete view. We are not saying that it's a complete representation. We have solved the big old myth of data quality. It's just how we are solving and how we plan to move forward as we move along in this journey, right? With our customers. Yeah, sure.
Yeah. And also the number of tests which we are performing and recommending for use cases based scenario, right? That also we have a larger and broader range of tests which we are performing. So apart from that, yeah, we can take up the questions offline since we are running out of time. But like as said, we would love to hear your feedback and what you.
I think we can continue. We can take a couple of questions if there are any. We can. Yeah, please.